materials that are used in electronics. All materials are made up of atoms. These atoms contribute to the electrical properties of a material, including its ability to conduct electrical current. In terms of their electrical properties, materials can be classified into three groups. First is insulators. An insulator is a material that does not conduct electrical current under normal conditions. Valence electrons are tightly bound to the atoms. Therefore, there are very few free electrons in an insulator. Examples of insulators are rubber, plastic, glass, etc. Second group is conductors. A conductor is a material that easily conducts electrical current. In conductors, valence electrons are very loosely bound to the atom. These loosely bound valence electrons become free electrons. Therefore, in a conductive material, the free electrons are valence electrons. Most metals are good conductors. The best conductors are single element materials such as copper, silver, gold. In addition to metals, salt can also conduct electricity. There are no free electrons in salts, so the conductivity depends on ions. When a salt is melting or dissolving, these ions are free to move. Third group of materials that are used in electronics include semiconductors. A semiconductor is a material that is between insulators and conductors in its ability to conduct electrical current. A semiconductor in its pure or intrinsic form is neither a good conductor nor a good insulator. There are two types of semiconductors. First is single element semiconductor. The single element semiconductors are characterized by atoms with 4 valence electrons. These single element semiconductors are silicon, antimony, arsenic, boron, etc. Second type of semiconductors are compound semiconductors. Compound semiconductors are semiconductors that are made from 2 or more elements. Compound semiconductors such as gallium arsenide, silicon germanium, silicon carbide are most commonly used. Silicon is the most commonly used semiconductor. It is a sand particle in pure form. At 0 Kelvin, silicon is an insulator. Silicon gets better at conducting electricity as the temperature increases. So, the crucial difference between conductors, semiconductors, and insulators rely on their level of conductivity. This conductivity depends on valence electrons. If these valence electrons are loosely bound to the atoms, then they become free electrons and conduct electrical current, such as in conductors. If these valence electrons are tightly bound to the atoms, then they do not become free electrons and do not conduct electrical current, such as in insulators.